Thank you, Paul, and thank you to Invivoscribe for inviting me to present this data today. I'm going to talk about our use of the Invivoscribe kits to analyze IGVH mutational status, T-cell clonality, and MRD by NGS. So as I said, we've been looking at the IGH and TCR beta. We've looked at clonality assessment in using both kits. And for the IGH, we've also looked at IGVH mutational status. And for both IGH and TCR, we've also looked at MRD status and how the Invivoscribe kits could be used for these assessments. All the assays that I will talk about today, all the data, have, as I said, we've used the Invivoscribe LymphoTrack kits on the Illumina MySec instrument. We've looked at CLL samples for IGH mutational status, and we've looked at ALL samples for MRD using the LymphoTrack IGH kit, and we've used the LymphoTrack beta kit for looking at clonality in T-cell samples. This schematic, just taken from the Invivoscribe website, really I included this just to highlight the workflow involved in all these kits that we've used. It really is a very simple process right from the start, where you prepare the DNA, the primers are all pre-mixed, one-step master mixes, and everything really from start to finish is included in the LymphoTrack kit. So the bioinformatics and that I'll show some data from, and also the MRD software. So I'll start by just talking a bit about IGH mutational status in chronic lymphocytic leukemia patients. And as I said, we used the LymphoTrack FR1, 2, and 3 assay kits. So why measure IGH mutational status? Even in the era of novel therapies for CLL, the IGH mutational status still has a place, and particularly with the longer follow-up of trials of the fludarabine, cyclophosphamide, and rituximab regimen, it really is still a very valuable prognostic factor. This data, taken from the MD Anderson's FCR 300 trial with extended follow-up, really sort of highlights this. And you can see that, so essentially just the definition of IGH mutational status first. Unmutated cases are deemed to be those cases with greater than 98% homology to germline. And as I said, unmutated IGVH status in CLL is regarded as a poor prognostic factor. So, as I mentioned, the extended follow-up of this FCR 300 trial is really sort of highlighting that in approximately 50% of cases, highlighted here in red, these patients are essentially cured of their disease, and the follow-up is continuing. And really, this CLL for many years has been, and still probably is, regarded as an incurable disease, but there's obviously approximately 50% of cases just on IGVH status alone that may be cured with the FCR regimen. So for both the IGH mutational, IGH and T-cell clonality assessments, we've used a method that was published by Arcilla et al., and we heard just next door, just in the last couple of talks, about the use of this, the definition of clonality. Essentially what we did was we looked for clones, we looked for greater than 50,000 total reads in the sample. That is a sort of a quality control step. We then looked for the first or second most frequent reads as being greater than 2.5%. If that rule was met, then we looked for the first or second reads being greater than 5 times the fourth most frequent unique read. And if that rule, the third rule, was met, then we sort of deemed that to demonstrate clonality. The table at the top there is just an example of one of the outputs from the IGH LymphoTrack. That was from the TR beta LymphoTrack assay, but it just highlights the breakdown of the reads. From that IGH Clonality, we were then able to put the sequence into the IMGT database, and from that database make a decision on the somatic hypermutation status of the sample. And in this particular case, you can see that by Sanger sequencing, the sample was deemed to be biclonal or have what's called a pseudogene. But by NGS, we identified the same two clones, but only one of them was productive, shown there at the top. So, I mean, that just highlights in one sample that NGS was more definitive in a way than the Sanger sequencing result. This is just that result plus one other where we've demonstrated Sanger sequencing was more definitive than the LymphoTrack assay was more definitive than the Sanger sequencing. So the first one on the left there is the same pseudogene sample, and the right is another biclonal sample where one of the clones we identified by NGS was unmutated and the other clone was unproductive. And in both cases, both clones were identified by Sanger, but the result was less conclusive. So moving on, T-cell receptor clonality. Again, we use the LymphoTrack TR-beta kit on the MySec instrument. This data just shows an example of a clonal and an oligoclonal sample, and you can clearly see that in the clonal sample on the left there really is only the one peak, and on the right we've got a polyclonal picture where the most frequent read was only identified in 0.87% of the total number of reads. Again, we used the same definition of clonality, and we correlated our results with direct sequencing. In total, we analysed 28 samples from 25 patients, and the breakdown of the T-cell disease is shown there in the pie chart. The important message from this slide really is that the samples were taken from various different sites within the body, and including 6 FFPE samples, but all the samples had greater than 50,000 total reads. The concordance with the PCR was very good, and you can see the breakdown there at the bottom. 16 out of 17 samples were clonal by both methods, and interestingly, 2 out of the 11 samples that were polyclonal by PCR were polyclonal by PCR were clonal by NGS. These are example cases of those samples. So you can see a sort of a polyclonal picture on the left where all clones were less than 2.5%. A clonal sequence in the middle where the dominant clone was identified in 44% of the reads, and on the right, this we sort of described as a clonal sequence because it had greater than the 2.5%, but it was in a polyclonal background. Now, we've heard yesterday from Dr. Bob where the actual sampling is probably very important, and as we're sort of unsure why this result looks how it does, but it was a clonal sequence, but there's a possibility that there's insufficient sample, actual disease sample within that sample. So the final part, my talk is sort of looking at MRD status, minimal residual disease status. And coming back to the data from the MD Anderson FCR 300 trial, on the left there is the plot that I showed earlier with IGVH status. If you combine IGVH status with MRD negativity at the end of the treatment period, you can see you can improve the outcome of patients, or the outcome of the patients is significantly better if they're MRD negative and IGVH mutated at the end of treatment. So that really sort of suggests that MRD could be a surrogate for progression-free survival, particularly in a disease like CLL where the long-term follow-up is really necessary to sort of determine the outcome or of the trial. This data from the CLL8 German trial really just shows that in addition to the MRD negativity, the level of MRD at the end of treatment really does impact on disease outcome as well. So we've used the LymphoTrack MRD software to interrogate our samples for MRD status, and this just shows you an example of the LymphoTrack MRD software, where you can either use the T-cell assay or the IGH assay. You can input your sequence of interest and then interrogate your sample for that sequence. And this is the output from that software. So the sequence that we looked for is shown here. The total number of reads, as you can see, was around 600,000. And then the output really gives you a level of MRD where it's identified the exact sequence or one or two mismatches in that sequence in the sample that you're interrogating. Our initial, without having had any actual clinical samples, our initial assessment was to spike a clonal control into a polyclonal control at various different levels. And you can see the levels that we spiked the sample at here. The concordance between the dilution and the read frequency that we identified the clone at was very good, so we were confident that we were sort of within a sort of a linear range. This is just an example of the diagnostic sample. So or you can imagine this would be the diagnostic sample. This is the clonal control that we spiked into a polyclonal control, and you can see at the lowest dilution, 0.005%, the clonal sequence was identified in 33 reads out of the 600,000, and that gave us a frequency of 5 × 10⁻⁵. And you can imagine that this would be go from a sort of diagnostic scenario to a post-treatment or query relapse sort of assessment. So the next thing was to move on to some actual real-world or clinical trial samples, and we were able to get access to a BALL trial, the ALL6 trial in Australia. And this assessment here is just one patient from that trial that we assessed at different time points of the follow-up. So in the diagnostic sample, you can see clearly clonal peak in the day 36, 99, and so on. That sequence appears to disappear, but when we run the actual MRD software, we can still detect that, shown here in grey using NGS, and shown in comparison allele-specific PCR. You can see even at the latest time point, there's a significant difference in the level of MRD detected. But the issue with that is that there was at the time we didn't have a sort of internal control, so we were unsure whether that was actually a significant difference or whether this we were going to sort of had to normalize this, but we were confident that at least at that time point it seemed that it was a sensitive assay. Just recently as last week, we generated some data with a control that I believe will be available in the future from Invivoscribe, and we spiked a sort of sequence in at a known cell equivalence into our samples. And these are two more samples from the ALL6 trial. You can see the first sample taken on day 36 was negative by allele-specific PCR, but we detected it as a level of 10⁻³ using the LymphoTrack and MRD software. In the second patient sample taken at 2 time points, day 34 and 86, the level by allele-specific PCR shown here in blue, but we were significantly more sensitive at 10⁻² using the NGS assay. So really we're more confident by having something to normalize our data against, that we're actually quantifying correct levels of MRD. And this is very much ongoing with more trial samples. So just to summarize, I think I've demonstrated the NGS LymphoTrack assays are very sensitive. There's a very efficient workflow, and it's intuitive software, both the Clonality and MRD software. Something we haven't done much of, but is possible using these assays, is that you can multiplex different assays. So you can multiplex the IGH, T-cell, and I believe up to 96 samples have been run simultaneously on one flow cell, therefore sort of cutting costs significantly. We've shown that it can be applied to a range of tissues, including archival tissue, so even sort of formalin-fixed, paraffin-embedded. There's a very good correlation between the NGS assays and direct sequencing. As I said, the thing that we're working on at the moment is MRD quantification using the LymphoQuant assay, and we're going to continue looking at samples from the ALL6 trial. So with that, just leaves me to thank the following people, in particular Associate Professor Will Stevenson, Dr. Linda Lee, Mary Collith from our institute, and also Rosemary Sutton from the Children's Cancer Institute of Australia. Thank you. I'm happy to take questions.
Thank you, great talk. Cecilia from Fred Hutch Cancer Research Center. For the MRD quantification you're doing with the LymphoQuant, have you performed specific copy numbers in a titration experiment to essentially do that to ensure you have the right numbers?
Do you mind repeating the question? Because at the back is
Hello? Okay. So the question is, for the MRD quantification with the LymphoQuant assay, have you performed specific numbers where you know the input copy number on say, a plasmid or something like that, and done that type of experiment to make sure you have the right copy numbers?
Yeah, no, we haven't done that yet. As I say, that MRD quantification is very sort of early stages at the moment. The LymphoQuant control comes as a cells equivalent. So we spiked in 100 cells equivalent, so that's how we sort of generated the MRD level. But we are talking about having a sort of a sequence, a plasmid that we can spike in and sort of measure that. But that would be, obviously these samples are quite precious, and so we're a bit limited by that. But yeah, that's something we will be doing.